Okay, so for this video, we will be covering our structure-activity relationships for our barbiturates. Our SARs for barbiturates aren't too much, so this would be a very short video. So our parent compound for our barbiturates is our barbituric acid, also known as our malonylurea or our 6-hydroxyuracil. So the image is cut, but it's O here and R1, R2. Okay, so it's a cyclic compound. However, it is not aromatic, and you can see that it has two nitrogen atoms within the ring. The most important number you should remember is 5, because 5 holds the position for two substituents that affects its SAR. So for the numbering, you have nitrogen 1, carbonyl at 2, nitrogen at 3, carbonyl at 4. 5 is a plain carbon and 6 is another carbonyl group. Now a tip for you to easily find number 5, simply look for two carbonyl groups which has a plain carbon in between them. So in this case, this is not nitrogen, so it's a carbon. And opposite that is number 2. So if you can identify 5, you can also identify number 2. And you can proceed with numbering the structure as needed. Okay? Now here is the summary for SARs. You can look at it or you can take a screenshot, but we will go over the SARs one by one. So first is that barbituric acid is 2,4,6-trioxo-hexahydropyrimidine, and this is the structure you see on the screen. It has no CNS depressant activity. However, if you replace hydrogens at number 5 here with alkyl or aryl groups, you can actually induce the structure to have the activity of our barbiturates. So substitution at 5 is mandatory for you to have an activity. If it's only double H or 2 hydrogen atoms, you won't have any activity. So in general, increasing lipophilicity also increases hypnotic potency and the onset of action and decreases the duration of action. Increasing lipophilicity increases effect, increases onset of action, meaning it's faster. Onset of action is the time or the delay time between ingestion and effect. So it's faster for the effect to kick in. However, you have a shorter duration of action, meaning your effect doesn't last as long. So the opposite is also true. If you reverse the relationship, you have a lesser effect, a slower onset, but a longer duration of action. Okay, so beginning with the lower alkyls, there is an increase in onset and a decrease in duration with increasing hydrocarbon content up to the 7 to total 9 position. Okay, so at 5 right here, you can substitute alkyls. You can substitute methyl or ethyl or any longer subchain. However, there is a limit. If the sum of the carbon atoms at positions 5, so you can add 2 chains of hydrocarbons at 5. If the sum of those the sum of the total carbon atoms surpasses 7 or 8, the activity drops and produces no effect. So meaning, take for example, this is 5 position. You have, let's have ethyl, di ba? Let's have propyl and ethyl. Okay, so the sum of this is 1, 2, 3, 4, 5. It's 5, it's still good. It's still active. However, if we have an example like this, this is butyl, dibutyl, two butyl groups. The sum is 8. There is no activity. Okay, so the total carbons 1, 2, 3, 4, 5, 6, 7, 8 substituted to the fifth position should not surpass 7 or 8. Okay, and there is an inverse correlation between the number of carbons and the duration of action. So the higher the number of carbon atoms, the shorter its duration of action. This is actually corollary to this one. Next is our thiobarbiturates. So if we replace the oxygen atom at position 2, remember this is 5, this is a plain carbon surrounded by 2 carbonyl groups. The opposite one is 2. If you replace oxygen with sulfur, you can form a thiobarbiturate, like our thiopental. It produces a rapid onset of action. However, you have a shorter duration. And this is the reason why our thiopental is primarily used in anesthesia, to induce anesthesia, because it kicks in fast and it disappears fast as well. So it can be replaced by other general anesthetics. And that is the summary, or that is the conclusion of this video. Those are all the SARs for our barbiturates. So as I alluded to earlier, the structure activity relationships of our barbiturates are very few. Okay, so that's all for this video. Thank you for coming. I hope you have learned something, and see you again on a future video regarding our SARs. Thank you.